Slide 1. Today, we delve into HBM4 and the material singularity of 2026, bottlenecks in AI server supply and opportunities for Japanese companies. In 2026, the semiconductor industry will enter a phase known as the material singularity. Chip manufacturing technology will no longer be able to keep up with the speed of generative AI evolution. The key to breaking through this limit is no longer miniaturization equipment. It is chemical materials. SK Hynix, Samsung Electronics. Behind the hegemony war waged by these memory giants, it is actually Japanese companies like Namix, Resonac, and Fujimi that are determining the outcome. Why will a supply crisis occur in 2026? And which material manufacturers hold the choke points? I will unravel the chemical war that investors often overlook with dense original analysis. Slide 2. Why HBM4? The logic process revolution. First, let's review why a new memory called HBM4 is needed now. The reason is simple: the memory wall. The latest AI models have reached trillions of parameters, and data read speed is hindering performance more than calculation speed. In the current HBM3E, the road width bus width was 1024 bits. In HBM4, arriving in 2026, this will instantly double to 2048 bits. Furthermore, the biggest innovation is adopting cutting-edge logic processes for the base die at the bottom of the memory, instead of traditional memory processes. By using TSMC's 12mm or 5mm fine processes, it becomes possible to give the memory itself advanced computing capabilities. While this dramatically improves AI training and inference efficiency, the cost is a skyrocketing manufacturing difficulty. Slide 3. The Great Divide, MRMU versus hybrid bonding. In HBM4 manufacturing, the industry is split right down the middle into two camps. This is a battle between evolution and revolution. The first is the MRMUF technology adopted by the current king, SK Hynix. This method involves pouring liquid resin into the gaps between stacked chips to solidify them. The second is hybrid bonding, which the challenger Samsung is betting on. This is the ultimate technology that directly bonds copper to copper at the atomic level, without using resin or bump solder. Theoretically, hybrid bonding is superior, but manufacturing is extremely difficult and yields are unstable. Who will win in 2026? In fact, this technical choice determines the winner of the supply chain. Slide 4, the winner's moat, SK Hynix and Namix. First, let's approach the secret of SK Hynix's current runaway strength. They decided to dare to continue with the existing MRMUF technology, even for the 16-layer stacking of HBM4, because they have the strongest partner. That is Namix, a Japanese company headquartered in Niigata. The special liquid encapsulant supplied by Namix penetrates the narrow gaps between chips like magic and efficiently dissipates heat. As long as this material exists, SK Hynix can mass-produce HBM with high yields without introducing expensive new equipment. Namix material technology is the strategic moat of SK Hynix that competitors cannot imitate. Slide 5. The challenger's strategy. Samsung's total war. On the other hand, Samsung, which has fallen behind, views the early transition to hybrid bonding as its main bet, while aiming to regain share by any means necessary. The logic is that if bumps are eliminated, thinner and cooler memory can be made. However, the nanometer wall stands in the way. If the copper surface is even slightly uneven, it cannot be bonded. To achieve this flatness, Samsung is desperate to develop manufacturing processes in partnership with the Dutch equipment maker, Besi, and Japanese material manufacturers. They are deploying a total war strategy, hedging risks with improvements to existing technologies while aiming for a reversal with new technology. Slide 6, the CMP battlefield, Fujimi and Resonac. Holding the key to the success or failure of Samsung's hybrid bonding challenge is the process called CMP chemical mechanical polishing. It is the technology to polish the surface flat at the atomic level. The required precision here is a surface roughness of 0.5 nanometers or less. Japanese companies Fujimi Incorporated and Resonac hold absolute power here. The CMP slurry polishing agent they make controls a godlike chemical reaction that polishes while dissolving copper and insulators at different speeds. In the HBM4 era, the more hybrid bonding spreads, the value of this polishing technology will rise exponentially. They possess the alchemy to turn process difficulty into profit. Slide 7, the film giant Resonac's NCF strategy. Resonac has another face. It is the face of the world's no. One company in the TC-NCF method, or film-type adhesive, currently adopted by Samsung and Micron. Solid Resonac versus liquid Namix. Resonac is currently developing next-generation films with enhanced heat dissipation, launching a countermeasure against liquid materials. Regardless of whether the HBM stacking method becomes liquid, resin MUF or film NCF, the composition that Japanese material manufacturers are at the center remains unchanged. Slide 8. Photoresists. The thick film challenge. Not just stacking technology, but connecting technology is also important. In HBM4, fine lithography comparable to front-end processes is required for connection with cutting-edge logic, dies, and hybrid bonding. Here, the photoresist technology of Tokyo, Oka Kogyo Tok, and JSR comes into play. Unlike normal semiconductor manufacturing, packaging requires processing with thick film resists. Also, in the technology of temporary adhesives to support wafers thinned like paper, Tokyo, Oka Kogyo holds a high market share. These are plain but extremely important stagehands that determine yield. Slide 9. The 2026 supply crisis. Now, based on these, let's predict the market in 2026. In conclusion, a severe HBM supply shortage will occur. HBM4 has a large chip size and stacks 16 layers, so it consumes a massive amount of wafers to make just one. Cannibalization occurs where lines for making standard DDR5 memory are taken for HBM. Furthermore, 16-layer stacking is technically difficult, and initial yields will likely be low. While SK Hynix is stable, if Samsung's introduction of new technology faces difficulties, the total supply volume of the market will fall significantly below plan. This could restrict the shipment volume of NVIDIA's next-generation GPU, Rubin, due to memory shortages. This is the biggest market risk brought about by the material singularity. Slide 10. Conclusion. By the chemical monopolies. In conclusion, the war over HBM4 looks like a battle between Korean memory makers on the surface. However, it is actually Japanese material manufacturers who are deciding the outcome. SK Hynix is strong because they have the strongest partner, Namix. For Samsung to reverse the situation, the cooperation of Fujimi and Resonac is essential. Investors, when you hear the news that HBM is in short supply, do not just look at the memory makers, but focus on the chemical manufacturers holding that bottleneck. Namix, Resonac, Fujimi, Tokyo Oka Kogyo. The true rulers of the AI era might be them, casting chemical magic on top of silicon.